Hey Math 2 students, this is Mr. Flynn. These are your notes for April 27th on Monday. Notice they're the same start of the notes of what we did last week. This is all the work we did last week. Now the notes from last week are not here, so this is blank, but you should have those from last week. So I'm going to start here with the quadratics, forms of quadratics and their characteristics. So the forms are pretty simple. We have what's called standard form, and you've seen that. We may not have called it standard form. You've seen factored form, and now we're going to add vertex form a little later this week. But the characteristics are simple. The characteristics are, we're going to look at in standard form and or factor form, and we're going to be able to say we see the y-intercept, or we see the x-intercepts. And remember, the x-intercepts are the roots, the zeros, the solutions, all right? The vertex, remember the vertex, if we have it concave down, is the top point, right? If it concaves like this, then that's the vertex, right? And then we have what's called the axis of symmetry. And the axis of symmetry is that dotted mirror line that goes right through the vertex, right? So we're going to be able to see those, or at least figure them out pretty quick with some math, all right? So with that said, I'm going to go into standard form, which is what we've seen here. And that is the ax squared plus bx plus c, where a is not equal to 0. And what they're saying is there's a number multiplied by the x squared, there's a number multiplied by the x, and then there's the number being added or subtracted at the end, okay? A cannot equal 0 because if a is 0, 0 times x squared would cancel that out, and we wouldn't have an x squared. And to be quadratic, there needs to be an x squared, okay? So let's get that out of there. And what we're going to do is we're actually going to identify the a, the b, and the c first. Because once we are able to identify the a, b, and c, we can find out most all of this information right now. So in example 1, where it says f of x, remember, f of x can be y, but we have x squared plus 6x plus 8. The a value is 1 because nothing's there, so a equals 1. The b looks pretty simple, right? The b equals 6, and the c is pretty simple. C equals 8. Not too hard, right? We got that down. So we move to the second one. Again, the a value, or the number being multiplied by the x squared, is not there, so it's 1. A equals 1. In this case, b equals, there's nothing here, so it's 1, but because it's being subtracted, the b is a negative 1. And then the c is just at 12, but because the 12 is being subtracted, it's negative 12. And then last but not least, we have now a leading coefficient, a leading number in front of the x squared is negative. So it's negative 1. So the a is negative 1. The b is, looks like, 15. And the c is negative 54. Okay? Now we're going to use these exact same 3 problems to find all those characteristics. We're going to find the x-intercept. We're going to find the axis of symmetry. We're going to find the vertex, and then we're going to find the roots in that order, okay? So now that you can find the a, b, and c of a quadratic, we'll use them, and what we know to find the axis of symmetry, the vertex, the roots, and the y-intercept. So pretty simple. In standard form, when you have it in standard form just like this, not in any other form, don't worry about that, just in this form, the y-intercept is when x equals 0, and the y is the c. Or, in this case, a equals 1, b equals 6, and c equals 8. We did that already above, up here. Okay? So, we know the c is 8. So that coordinate, 0, 8, is the y-intercept. So we know that's where it'll cross the y-axis. Okay? So now here's the newest part. It's the axis of symmetry. The axis of symmetry, if you remember, okay, a parabola, wherever it is, whether it opens up, right? That axis of symmetry is that dotted line, and that's x equals a number. Well, how do we find that number from standard form, we use the formula opposite of b over 2a. So all we do is write x equals, and then this means opposite of b. So the opposite of b, which is negative 6, over 2 times a, or 2 times, and a is 1. So that's negative 6 over 2, which is negative 3. So the axis of symmetry is negative 3. So finding the axis of symmetry is very important because it's not hard. And this little formula, please just have it in front of you all the time. But once you find the axis of symmetry, then it's easy to find the vertex. So we take this f of x and we take it out and we make it the y. Remember we said that could be a y. So y equals x squared plus 6x plus 8. Now, we know the axis of symmetry if we come back to here, right? If we come back to here, we know that that axis of symmetry, wherever that is, it runs right through the vertex. So if x equals negative 3 on that axis of symmetry, the x equals negative 3 at the vertex. So if we take this x equals negative 3, plug it into all the x's here, and then solve this, we'll get the y value of the vertex. And then we'll have the coordinate. We always know that the coordinate will be negative 3 something because we get that negative 3 there. We just need to figure out what that y is. So let's take that negative 3 and put it into x squared. So we use a parenthesis negative 3 squared plus 6 times negative 3 plus 8. Negative 3 squared is negative 3 times negative 3, which is a positive 9. Positive 6 times negative 3 is a negative 18 plus 8. And then 9 plus negative 18 is negative 9 plus 8, which is negative 1. So y equals negative 1, and we'll put that negative 1 in there. So our coordinate is negative 3, negative 1. That's our vertex. Okay? So the key is know how to find the axis of symmetry in standard form. Take that number, substitute into the equation, into the quadratic, to find the vertex. Okay? And now the last part. The last part is finding the zeros, finding the roots, finding the x-intercepts. So this is the x-intercepts, okay? We could have 1, we can have 2, or we could have none. Now, you did this last week, but what you have to remember is they're giving you f of x. So all you do is take the f of x out and make it 0, because we know if we were to graph this, if the parabola were to go like that, it's when y is 0, this is the y value, when it's 0, okay, we'll get our x's, or our x-intercepts. So we set the equation equal to 0. So we set the quadratic equal to 0, and now we're going to use factoring. We always look to see if our leading term is negative. If it's not, then we factor like we normally did. It's a 1 here, so 1 times the 8 is 8. List the factors of 1 and 8, 2 and 4. That's an easy one. So the last term is positive, so both the signs are the same. The middle term is positive, so they're both positive. Which pair will give you positive 6? Right here. So we get 0 equals x plus 2, x plus 4. So we just did factoring like we did last week. Now, and I want to erase this over here to give me some room, we take each one, set it equal to 0, and solve. X equals negative 2. Take the other one, x plus 4 equals 0, and solve. So those are the solutions, or if they want the actual x-intercepts, meaning as coordinates, then what we do is we write two coordinates. When x is negative 2, y is 0. And when x is negative 4, y is 0. Okay? So you may have to give it that way or this way, or if it's multiple choice, know that they could be given in two different ways. Okay? So now we're going to use the same things over and over again. We're going to do all three. So our second example is, let's get our A equals 1, B equals a -1, and C equals -12. So we know that the y-intercept is 0 in C. We're done. We know the axis of symmetry is x equals the opposite of b, so that's a +1, over 2 times a, which is 1/2. Okay? So now we got a fraction, but we can still do this. You can use your calculator. So now that we get the axis of symmetry, we now take the function and we write y equals x squared minus x minus 12. And what do? Think about what we just did up here, okay? When we found the axis of symmetry, we substituted it into the function. So now that we have the axis of symmetry, we're going to substitute that into the x here, into the x there. So we're actually going to get 1/2 squared minus 1/2 minus 12. 1/2 squared is 1/2 times 1/2, which is 1/4, minus 1/2 minus 12. When I do this, you can use a calculator. I'm going to do it kind of quick here. I'm just going to give you the answer. But when I work this straight through, I'm going to get a -12 1/4. Okay, -12 1/4, which means I'm going to get a vertex of the x value is here, 1/2. The y value is what we just solved, -12 1/4. Okay? Then, to find the roots, we take the exact same function, I'm going to use a different color, and we make it equal to 0. My leading term is a 1. 1 times 12 is 12. That's 1 and 12, 2 and 6, 3 and 4. The last term is negative, so the signs are different. The middle term is negative, so the larger ones are negative, which to give me a -1 right here. So I get 0 equals x plus 3, x minus 4. And now I just solve. X plus 3 equals 0. Solve that. X equals -3. X minus 4 equals 0. Solve that. X equals 4. And again, if they want coordinates, we get -3, 0, and 4, 0. There's your coordinates, okay? Now, before I go any further, I'm going to go back up here. I'm going to use a different color now, okay? I'm going to use this color. What I want you to realize is we need to know if this opens up or down. And that's easy. We look at the A term. If the A is positive, it opens up. If the A is negative, it opens down. Okay? So this opens up. So if it opens up, they're going to ask you, is the vertex, or is it a max or minimum point? Well, we know if it opens up like a cup, the bottom is a minimum point. So this one opens up concave, I should say concave up with a minimum point. If we go to number 2, okay, the A is positive. So since the A is positive, concave up, and again, minimum. Okay? So keep that in mind when we come down here. All right, number 3, where our A is -1, our B is 15, and our C is -54. So we know if the A is negative, that it concaves down. And if it concaves down, it has a maximum point. So those are two pieces we didn't really go over too much, okay? So I'm going to just erase this to use that space. Now, knowing that, we have a y-intercept of 0 and c is negative 54. Perfect. Axis of symmetry. X equals the opposite of b. So b is 15. So the opposite of b is negative 15 over 2 times a, and a is negative 1. And that becomes negative 15, and 2 times negative 1 is negative 2, which is positive 7.5. Okay? Pretty good. So now, and again, I'm going to kind of speed up for time here. I don't want to keep you on the video too long. We use the axis of symmetry in the function, and we write y equals the function negative x squared plus 15x minus 54, and we substitute that in for the x's here to get the x value of the vertex, so that we have an x, which is this, and a y, which is this when we solve. So the negative, and we have 7.5 squared plus 15 times 7.5 minus 54. Okay? So, quickly, let's see what I get here on my calculator. I'm going to have 7.5 squared is 56.25, but that negative does not come off it. It's a negative 56.25 plus, clear this off, I get 15 times 7.5, and if you want to use decimals, you can. 112.5 minus 54. So if I have a 56.25, and that's negative, I'm going to add 112.5, and then I'm going to subtract 54, and I'm going to get, let me see if I get this all right. I get 2.25. Okay? So, if this is the y, I get the x is 7.5 or 7.5, and then the y is 2.25 or 2.25. All right? So either vertex will work. Okay? Now, this is a little bit of a change here, only for the fact that we need to find the roots. So this is now equal to 0. We set it equal to 0. Negative x squared plus 15x minus 54. Okay? So with that said, we can factor out, we got to have this to be a positive number. So we want to factor out a negative 1. And it leaves x squared, because if I divide that by negative 1, that leaves just x squared. If I divide this by negative 1, it's negative 15x. Divide that by negative 1, I get plus 54. And that equals 0. Now the ironic thing here is, to get rid of that negative 1, to get away from it, let's divide both sides by negative 1. And that just cancels out, and 0 divided by negative 1 is actually 0. And then we're left with x squared minus 15x plus 54. Okay, now we factor. So I'm going to use a lot of space here. I'm going to multiply 1 times 54 and get 54. Now, knowing your factors is not hard, but working with them takes some time. So I have 1 and 54. These are both even, so 2 goes into there, and I can use my calculator, but that's 27. Now I know, I know 54 is divisible by 3, because I did the old 5 plus 4 equals 9. So this is called a digit sum. You take these two digits and add them, and if your sum, that answer, is divisible by 3, then the whole thing's divisible by 3. So 3 goes into 54. Again, I can use my calculator 18 times. 4 does not go into it, 5 does not go into it, 6 goes into it 9 times. So the last term is positive, so they're both the same. The middle term is negative, so they're all negative. Which pair give you negative 15? Right here. So I get 0 equals x minus 6, x minus 9, and now you just solve. X minus 6 equals 0, x equals 6. X minus 9 equals 0. X equals 9. Or the coordinates could be 6, 0, and 9, 0. And that's it. Okay? Any questions? You should be able to follow this pretty good. I hope it helps. If you need any help, just let me know. Thanks. Have a great day.